Hi everyone, today's lesson we're going to look at cubic polynomials. With me here is an exam type question. The description reads, as sketched below is the graph of f of x equals to x cubed plus ax squared plus bx plus c. The x-intercept, each time you read a word or words in maths that provide a concept, you should note it down. X-intercept means y is equals to 0. Of f are at 3, 0 and m, where m lies on the negative x-axis. K0 is the y-intercept. Whenever you hear y-intercept, you must remember that x is equals to 0. It's the point where the graph will cut the y-axis. M and n are the turning points. When I hear turning points, I remember that the first derivative is equals to 0. Now, by doing this, whenever you read a word and you have a concept on it and you write it down, it at least minimizes the time taken before you start writing something on a paper, which reduces panicking. Now, this is the description and this is the graph, the cubic polynomial we are talking about. It shows surely that m and n are turning points, k is the y-intercept, and 3 and m again are the x-intercepts. Now, let's look at the questions a bit and we start answering. The first question says, show that the equation of f is given by f of x equals to x cubed minus x squared minus 5x minus 3. Now, when a question says show that, it means whatever we are having here is our answer. And now we want to find how we can arrive at this answer. So whenever you are dealing with cubic polynomials, you need to remember the general formulas that exist for cubic polynomials. The first one, cubic polynomials can be written as ax cubed plus bx squared plus cx plus d. That's the first one. Then the second one says f of x can be written as a x minus x1, x minus x2, x minus x3. Now, this second format works when we have a cubic polynomial and we are sure, or we are given the 3x-intercept. We are given the 3x-intercept, which means this one will be your x1, your x2, and your x3. Now, number three, we can write cubic polynomials as f of x equals to a x minus x1, then x minus x2 squared. Now, this third one works if you have a cubic polynomial and it is cutting the y-axis, the x-axis, and at one of the points it is turning at the x-axis. So you'll be having a repeated root here at this point. Now, if you look at this third one and the question that we have, the graph that we are given is having a repeated root at this point. So for us to be able to find the required equation, we need to choose this option 3. So this is what is going to lead us to the solution. Now, so our answer to 9.1, we are saying we are selecting f of x equals to a is representing the coefficient of x cubed. And if you check, the coefficient of x cubed is 1. It's right here. It's 1. So our a is already there. So I don't need to write a again. So it's 1. Then x minus. Now, x1 is the x-intercept, so which is not repeated. So at this point, my x1, I will have 3 from this graph. I'm using the graph to substitute this. So wherever there is x1, I'm going to put my 3. Then my x2 will be this repeated root which I don't know. So I'm saying let x2 be this x coordinate at m. Now with this given, I can check also at the graph. We are given a third point which is k. Now with k given, we can use the coordinates there to find the value of x2. So we are saying we are using k with the coordinates 0, minus 3. is given by this graph here. So with that, wherever there is y, we are saying minus 3 is equals to, wherever there is x, I'm putting 0. And there should be a squared there, sorry. Now, with this, I need to make x2 the subject of formula. So I say minus 3 is equals to minus 3 at this point multiplied by 0 minus x2, that's x2, then squared outside. So we have x minus 3 is equals to minus 3 x2 then squared. I want to make x2 the subject of the formula, so I can divide both sides by negative 3. Divide both sides by negative 3. This and this cancels. This and this cancels. I remain with 1. So from this, therefore, my x2 is equals to 1. My x2 squared is equals to 1, which means my x2 is equals to plus or minus the square root of 1, which means x2 is equals to minus 1. We know there are two solutions here. The other solution is x equals to 1. The other one is x equals to minus 1. But we are rejecting this. We are rejecting this because if you check on the graph, we have our x2 on the negative side of the of the Cartesian plane. So x2 is negative, and it's given also in the description. Now, with this one done, the next job will be to substitute wherever there is x2, I am going to substitute minus 1. So at this point, I can now say therefore, my f of x is now equals to, it's 1 outside, then I have x minus 3, then I have x minus 1 squared outside. This is the x2 we got, which is this value here. That's the minus 1 we have. So I want to simplify this. I will have x minus x3, then this one becomes x plus 1, then squared outside. Now at this point, I need to expand this because our job is to find the general form in the form f of x equals to ax cubed plus bx squared plus cx plus d. So I need to expand up until it looks like this. We have a solution already. It is a show that question. So warning, on things that I've seen, people start by expanding, multiplying x minus 3 into this. It doesn't work. You should start by dealing with the bracket since you have this squared here. So it means expand. So here, if you expand this, you have x squared plus x times 1, that's x, 1 times x, you get x again, so you have 2x, then plus 1. Now after this, I expand everything, I multiply everything by x first. I have x cubed plus 2x squared plus x minus 3x squared minus 6x minus 3. Now simplifying this and grouping like terms, I have x cubed, 2x squared minus 3x squared, I have negative x squared. Then I have x minus 6x, that is minus 5x. Then this minus 3 comes as it is. So our f of x now is equals to the required solution. The question had said show that, so we found this as our answer. And it matches what the question wanted. It's a show that question. Now that we have managed to show, so we are done because the question said show that, and we have managed to arrive at the required solution. Now we move to 9.2. 9.2 says calculate the coordinates of n. When you read this, the question you should ask is, what is n? And if you remember the description or by looking at the diagram, we know that n is a turning point. Now, which means the first derivative here should be 0. Now, with that one said, so we want to answer 9.2. 9.2, we want to find coordinates of n. Now, at n, that the first derivative is equals to 0. We said this is a turning point. So our f of x is equals to x cubed minus x squared minus 5x minus 3 is the one given. Let me double check to be sure there. Now x cubed minus x squared minus 5x minus 3, right? So the first thing to do is to differentiate. So you get f prime of x is equals to 3x squared, let me change color, minus 2x minus 5. If you differentiate a constant, you get a 0. Now, from this, we are saying, therefore, at n, 3x squared minus 2x minus 5 should be equals to 0, because at a turning point, the first derivative is 0. Now, we are now solving a quadratic equation. Where a is 3, b is minus 2, and c is minus 5. So at this point, we are saying x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a, the quadratic formula. So it's negative. Now, this negative is for the formula. My b is negative 2, so I should include that negative. Then plus or minus the square root of, and it is important to put the negative 2 in brackets, minus 4, a is 3, and c is minus 5, then everything all over 2a, then I put 3. Now, most of you fellows, you use a Casio calculator. Now, at this point, you can feed everything as it is in a calculator and get the two values of x without needing to break down this into pieces. So if you punch correctly, the turning point, you will get the other value to be 5 over 3 and the other value to be minus 1. Now, this answer does not surprise me, and it is actually helping me to confirm whether my answers make sense. Because remember, we are given a graph, and we already found that our x2 here, we found the value to be minus 1. And if you look, it is also a turning point. So when we were calculating the turning point, I was really expecting to find minus 1. And the other x value we got, the 5 over 2, will be the one for n on this side. On this side here. 5 over 3, I mean. 5 over 3. Let me double check if I wrote this right. Yeah. Now, at the end, we want coordinates. So coordinates are written in the form x and y. So what is left is for us to find the value of y when x is equals to 3 over 2. We are choosing this one for n. So at the n, we are saying y is equals to, remember our equation, wherever there is x, we now need to substitute y in this original equation. So wherever there is x, we now want to substitute y. Let me write down the function close by. F of x is equals to x cubed minus x squared minus 5x plus minus 3, like that. So wherever there is x, I need to substitute with 5 over 3. So I can now say 5 over 3 cubed minus 5 over 3 squared minus 5, there's a 3 here, minus 5, then 5 over 3, then everything minus 3. If you punch the calculator on this, you will get your answer to be minus 256 over 27. So by so doing, we found the coordinates of n. Therefore, the coordinates of n are 5 over 3 and negative 256 over 27. We have found the coordinates of n. And answer analysis is always important. You need to go and check to say, does this answer make sense? Our x value is 5 over 3 and the y value is negative 256 over 27. We are below the x-axis, so it's the negative. So it makes sense to me. And with that said, this question is done. Now we need to move to 9.3. 9.3. So if you look at 9.3, it is saying for which values of x will f of x be less than 0. At this point, your language, the maths language, is being tested. You should be able to read this in English to say f of x, wherever there is this sign, it means less than, that's the first meaning. Then it also means below. In this case, we are saying we want to find values of x for which the function f of x, is below y is equals to 0, which means is below x-axis. So to answer this question and for 2 marks, we need to check the graph and see which parts of the graph are below the x-axis. So I'm going to erase some of the things I've written here to make things clearer. And here we got our -1 at this point. So now we are saying for which values is this graph below the x-axis. Now, if you look closely, you can see that for all the values from here, 3, going in this direction, for any value of x that you can think of, the function is clearly below the x-axis. But at this point, it is actually on the x-axis, and yet the question doesn't want that value. So we are going to say our values of x are all the values that are smaller than 3, but they must not be -1, so that we don't have this piece as our solution because it doesn't satisfy the given condition. So for us to answer the question 9.3.1, we are asked for x values for which f of x is less than 0. We can say the function is below the x-axis for every value that is less than 3, but it must not be equals to -1. The value that we got is our x2 here, at this point. So by so doing, we have also answered this question for 2 marks, and someone might write this answer to say in a different way, to say for all the values, if you check again, for all the values that are starting from -infinity here going up to -1, surely the graph is below the x-axis. And again, for any value that is greater than -1 but smaller than 3, the graph is also below the x-axis. So the solutions are x is less than -1, which means all the values in this direction, and also x is between -1 and 3. So someone can write the solution here for 9.3 as x is less than -1 and also x is between -1 and 3. These are all correct solutions as well for this. So you need to understand how to interpret these graphs that are given. Now, some might want to write this in another notation. Here we are saying starting from -infinity up to -1, and I have to use a curly bracket because this -1 is not included as my solution. And here I'm saying -1 up to 3. And again, I'm using curly brackets because the notation here is not does not demand for the end point values. That's it. So with this question is answered. Then we go to question 9.3.2. 9.3.2 says, for which values of x will the function be increasing where f is increasing? Now, we know increasing means going up. So if we look at this graph, you can see that here from negative infinity for all the values that are in this direction up to -1 here, surely the function is going up. Then we also have for all the values that are starting from this x value 5/3 going in this direction, for any value surely the function is increasing. So our answers for 9.3.2, I'll write them right here. 9.3.2, we want to say f is increasing, where f is increasing. Now if you look at this graph here, we are saying f is increasing for all the values that are smaller than -1. So we are saying f is increasing for all the values that are smaller than 1. And again, f is increasing for all the values that are bigger than 5/3. All the values in this direction, surely the function is increasing. So we are saying x is also greater than 5/3. This is how this question was supposed to be answered. Then we have question 9.3.3. We go to question 9.3.3. Question 9.3.3 says, for which values of x will f be concave up? Will f be concave up? Now, if you look at this, concave up, whenever you hear this word, whenever you see these words here, for concave up, it means the second derivative must be greater than 0. This is what gives you a formula that leads you to find the values of x as required. So we are saying for 9.3, the second derivative must be greater than 0. But what are we differentiating? So for question 9.3, for 9.3, we are saying 9.3.3, our f of x is given as x cubed minus x squared minus 5x minus 3. Now at this point, we now need the first derivative. So the first derivative is equal to 3x squared, 3 comes down, then minus 2x, then minus 5. If you differentiate a constant, like I said, you get 0. But at this point, we need a second derivative. We are going to get 6x minus 2 as our answer. Now, for this, we are now saying for concave up, we are saying the second derivative should be greater than 0, which means in this case, our 6x minus 2 should be greater than 0, and we are now solving an inequality. So 6x is greater than 2, then I divide both sides by 6. Therefore, my x should be greater than 1/3. Now we are saying the graph will be concave up for any value of x that is greater than 1/3. So now, if we go to the graph, 1/3, let's say it's supposed to be somewhere here. If I say 1/3 is somewhere here, then for any value that is greater than 1/3, which means I'm going in this direction, any value going in this direction, surely the graph is concave up. So to give you a concave up and concave down in pictures, we know that for concave up, the graph looks like this. Then for concave down, the graph looks like this. Then for this one, the second derivative is greater than 0, and here the second derivative is less than 0. So this is how this question was supposed to be answered. Now, there is also another way, and this is important. It's a reminder of a certain concept that you should also remember. Now, if you get a point of inflection, a point of inflection is the one that divides or that demarcates concave up and concave down. If I have a cubic polynomial like this, and this one is my inflection point, it divides this side as concave up, this one concave down. So there is a quickest way, if you have turning points, there is a quickest way of finding the point of inflection. So we should know that point of inflection is given by x1 plus x2 then O over 2. Now, where these ones are the x values of turning points. So from our graph, we found out that the x values of the turning points, here it is 5 over 3. The x value was 5 over 3 here, and the x value here is minus 1. So for us to find the point of inflection, we simply say, we are going to say this is equals to minus 1, the x value there, then plus 5 over 3, then everything divided by 2. Now if you do this, you are going to get x equals to 1 over 3. Now this is the point of inflection. So if you get x equals to 1 over 3, just like our graph shows there, now you go to the graph, then you put your x equals to 1 over 3 like we did here. I have my x equals to 1 over 3. Now, if you want concave up, you should know concave up by shape. It is every value that is greater than 1 over 3. Again, you can say you have arrived again at the same answer. To say, okay, therefore, concave up, for concave up, x should be greater than 1 over 3. You can use the graph to check this out. Now, answering the last question, it says determine the maximum. Whenever you see these words, you should remember also that they lead to first derivative equals to 0. The maximum vertical distance between the graphs of f and f prime. F prime is the first derivative, and f is the original function, which we said it is given as x cubed minus x squared minus 5x minus 3. So the derivative one is, it says 3x squared minus 2x minus 5. So they want the vertical distance for the interval minus 1 to 0, for all the values that are between of x that are between minus 1 and 0. Now, so to get a clear picture of this, the cubic polynomial is already sketched. Now you can sketch if you check, the first derivative here is a parabola. We know how to sketch a parabola, so you can sketch on top of this cubic polynomial a parabola, and I did that already. So this was the outcome. If you look at these graphs, you can see that this one is the parabola, which is now representing our f prime of x, which is 3x squared minus 2x minus 5, and this one is our original function, which is x cubed minus x squared minus 5x minus 3. Now the distance that is required, the question is specified to say for all the values that are between minus 1 and 0. So from this point, this is my minus 1, and this is where x is 0. So I want to find the vertical distance between here, maximum vertical distance. And using the word vertical, it means all these lines will be parallel to the y-axis. This is my y-axis. So all these are parallel to the y-axis. Now, to get this vertical distance, you need to remember this concept. If you didn't know, I think after this lesson you should be knowing this. To say distance along an axis, distance along an axis or a line parallel to the axis, will be, if it is along x-axis, it will be x2 minus x1. If it is along y-axis, it will simply be y2 minus y1. So by doing this, if I want the vertical distance between f of x and f prime of x, I simply need to say y2 minus y1. So in this case, my distance is given by f minus f prime, which is equals to, we know the function of f, it is x cubed minus x squared minus 5x minus 3, then minus the first derivative. If we differentiate it, we have been working with this, it's 3x squared minus 2x minus 5. So I need to simplify this distance because this is my y2 minus y1. The vertical distance is parallel to the y-axis, so it is y2 minus y1. Now, following this, it means now at this point, I can simplify and say x cubed minus x squared minus 5x minus 3 minus 3x squared minus 2x plus 2x, then plus 5 as well. Collecting like terms, I'll have x cubed minus x squared minus 3x squared, I'll get minus 4x squared, then minus 5 plus 2x minus 5x plus 2x, I'll get minus 3x, then here I'll get plus 2. Now this is the distance, but for maximum, as I indicated earlier, the first derivative should also be 0, which means x, I need to find that derivative. I need to find the derivative here. So I'll get 3x squared minus 8x minus 3. Now for maximum, which means for maximum, 3x squared minus 8x minus 3 should be equals to 0. We are now dealing with a quadratic equation where a is 3, b is minus 8, and c is minus 3. So at this point, we can go to the quadratic equation, which says, quadratic formula, which says minus b plus or minus the square root of b squared minus 4ac everything over 2a. Now where there is b, I put minus, there is minus, then I put minus 8 plus or minus the square root of, then minus 8 squared minus 4. A is 3, c is minus 3, everything over 2, a is 3. Again, we are back to this statement of saying, if you are using Casio, you can punch everything as it is and get the values of x directly. And if you do that, you are going to get the values of x. One, it's x equals to 3, and the other one, the value of x is minus 1 over 3. Now, the question does not want values of x, it wants the distance. So we are to choose from here the value of x, which will give us the maximum distance. We are going to reject this one. We are going to reject this because the question specified a condition. The question said for x is between minus 1 and 0. This was the condition. So 3 does not satisfy this condition, which makes our x to be minus 1 over 3. So we can now say, therefore, maximum distance, remember our d of x, we got our d of x to be this one, x cubed minus x cubed minus 4x squared minus 3x plus 2. So our d of x is x cubed minus 4x squared minus 3x then plus 2. So for maximum, we are now using the first derivative. The answer we got, our x value is minus 1 over 3. So wherever there is x, I'm putting minus 1 over 3 for our distance. Now, if you punch a calculator for this, you will get an answer 68 over 27. You can change this to decimal and round it to 2 decimal places as demanded by the instructions. So you will get 2.52 units. Now, in this lesson, in every question we answered, we reduced the time of waiting by reading and then marking important terms that led us to a concept. And here, each time I was reading, I was doing the same. Maximum, I know it leads to first derivative. Vertical distance, it is a story which is telling us that the lines that we are talking about will be parallel to the y-axis, and there is a concept which I wrote. So each time you are dealing with functions or any maths question, when you are reading the instructions or the descriptions, you need to make sure that you get the concept, you highlight the words that are leading to either the concept, the formula, or an equation, and you jot that down. It keeps you calm. So this is how you were supposed to collect the 23 marks for this calculus question. Thank you.